Hi and hello. So we're going to start our next unit all about congruent triangles. But before we talk about congruent triangles, I want to revisit what does it mean for two figures to be congruent. I figured that's a good place to start. So our lesson question today is exactly that. What does it mean if two shapes are congruent? Our goal is we're going to explore congruent figures. We're going to determine if two figures are congruent. We're going to find unknown measures of congruent figures. And we're going to identify corresponding parts of congruent figures. All right, so warm-up time. I'd like to go over rigid transformation. So take a moment, pause right here, and unpause it in about 3 seconds as soon as you're done with this warm-up to check the answers. All right, so here we have it. The three rigid transformations preserve angle measures and segment lengths of congruent figures. There are exactly three rigid transformations of reflection, which flips, a translation, which slides, and a rotation, which turns. Go ahead and skip the words to know. For now, we'll come back to it, and let's talk about congruent figures. Two figures are congruent if and only if one can be mapped onto the other by a sequence of one or more rigid transformations. So this definition works in either way. If the two figures are congruent, then there's a sequence of rigid transformations. Or if there's a sequence of rigid transformations, we know that figures are congruent. So A, B, C, D can be mapped onto A prime, B prime, C prime, D prime by a rigid transformation. And that's a reflection, right? Flip it over this line and they're the same. So A, B, C, D is congruent to A prime, B prime, C prime, D prime. And the opposite is also true. If two figures are congruent, so because QRST is congruent to Q prime, R prime, S prime, T prime, then there's a sequence of transformations that'll work, and it looks like it's just a rotation, maybe a translation as well. So we should be able to use this idea to determine if two figures are congruent. So we just need to look, is it possible for a sequence of transformations to map from one to the other? So let's look at this first one on the left. DEF has been rotated 180 degrees around point P, and then it's been reflected over line M. Because both transformations involved are rigid transformations, a rotation and a reflection, those are congruent. If we look at this next one, though, JKL, well, first it was rotated. Rotation does preserve shape and size, but then it's been dilated. We can tell it's been dilated because our side lengths got bigger. We went from 1.5 to 3, so it's been dilated, or it was a dilation by a scale factor of 2. It got made twice as big. So dilation is not a rigid transformation because it does not preserve segment length. Everything got bigger after that dilation. A single non-rigid transformation or a composition that contains a single non-rigid transformation will not necessarily produce congruent figures. So all three of those triangles are not congruent to each other. All right, so let's put this in action. Can we determine if these figures are congruent? As we scroll down, we'll check to see if DEFG and WXYZ are congruent. So it looks like if I take DEFG and slide it up, that gets me to the first D prime, E prime, F prime, G prime. So I got to translate it up. Let's count how far from E to E prime is up 6 units, and that should be the same everywhere, just to be sure. Let's count D to D prime. Yeah, it's also 6. So it looks like it's a translation up 6. And then if we reflect D prime, E prime, F prime, G prime over line Y, then it's congruent. So because it was a sequence of only rigid transformations, that tells us that DEFG is congruent to WXYZ. All right, then with congruent figures, we also have this other idea. If two figures are congruent, then their corresponding figures are also congruent, or corresponding parts are also congruent. With triangles specifically, we call this corresponding parts of congruent triangles are congruent, or CPCTC. With any other figure, we call it corresponding parts of congruent figures are congruent, or CPCFC. All right, so let's mark all our corresponding congruent bits, right? As in the name, corresponding congruent bits should be in the same place. So AB is congruent to DE, BC is congruent to EF, which, hey, that's already marked. And then AC should be congruent to DF. Now, it's important that I used 3 there just to signify they're the same, but they're not the same as anything else. Angles should also be congruent, so angle A is congruent to angle D. Angle B is congruent to angle E. And angle C is congruent to angle F. Right, congruent corresponding parts. Now let's use it with actual numbers. So, given PQRS is congruent to WXYZ, I just want to find all of the missing angles and side lengths on each figure. On PQRS, we're just missing Q, which is the same angle as angle X, so it has to be 94 degrees. And that one's done, so now let's fill in our blanks on WXYZ. So we'll start with XY, or WX rather. WX is the same as PQ, so it has to be 15 centimeters. And then similarly, YZ has to be the same as RS. RS is 8 centimeters, so YZ is also 8 centimeters. All right, let me know if you have any questions. Complete the words to know. Thank you so much.